Imagine you're standing in front of two cars that, at first glance, appear almost indistinguishable. Their paint gleams the same, their shapes are nearly identical, and to the casual observer, they might as well be twins. But pop open the hood, and you'll find a world of difference. One is powered by a reliable, everyday engine, while the other hides a state-of-the-art experimental powerhouse designed for performance that pushes boundaries. This is the perfect metaphor for the story of China's Mammoth 1 rocket engine and SpaceX's Raptor 3. Two engines that, on the surface, seem to be cut from the same cloth. At first glance, both engines look like siblings. They're both full-flow staged combustion engines, both burn methane and oxygen, and both represent the cutting edge of their respective countries' rocket technology. But in the world of rocket science, appearances can be misleading. What truly matters is what's inside. The engineering, the innovation, and the years of trial and error that shape each machine. The real story is about what these engines are capable of, how they were developed, and the philosophies that drove their creation. It's a tale of ambition, competition, and the relentless pursuit of progress. Mammoth 1, built by Landspace, clearly draws inspiration from SpaceX's groundbreaking work. The similarities in design are no accident. They're the result of studying what works and trying to replicate that success. Yet even if the plumbing and the layout look familiar, the differences run deep. Performance, reliability, and the stories behind each engine set them apart in ways that aren't obvious at first sight. One engine is racing to catch up, learning from the leader, while the other is setting the pace, blazing a trail into the future of spaceflight. To truly understand the gap between them, we need to look beyond the surface and dive into the details, the materials, the manufacturing, and the innovation that make each engine unique. Because the journey to space isn't just about copying what you see, it's about mastering the complex technology that lies beneath, and pushing the limits of what's possible. So let's peel back the layers, look past the surface, and discover why in the race for space, chasing a shadow is never the same as leading the pack. Let's talk thrust, the raw, explosive power that lifts rockets skyward and defies gravity. Thrust is the heart of any rocket engine, the force that determines whether a spacecraft can break free from Earth's grip or not. It's not just about going up, it's about how much you can carry, how fast you can get there, and how far you can go. SpaceX's Raptor 3 delivers a staggering 269 tons of thrust, an immense amount of force packed into a single engine. In comparison, China's Mammoth 1 aims for 200 tons, which is still impressive, but that 69-ton gap is significant in the world of rocketry. That difference means a Mammoth-powered rocket either needs more engines to match the lift of a Raptor-powered rocket, or it has to settle for carrying less payload. More engines add complexity, weight, and potential points of failure, while less payload limits mission capability. But it's not just about brute force, efficiency matters too. Specific impulse is the rocket world's version of miles per gallon. It measures how effectively an engine turns fuel into thrust, and higher numbers mean you get more out of every drop of propellant. Both engines use the advanced, full-flow staged combustion cycle, a cutting-edge design that squeezes every bit of energy from the fuel. But here's the catch. SpaceX didn't just adopt this technology, they perfected it first, blazing a trail for others to follow. Years of relentless Raptor testing led to engines that are not only more powerful, but also simpler to build, more reliable, and cheaper to produce. Every test, every failure, and every breakthrough has been folded back into the design. Mammoth 1 is just starting that journey. It's a promising engine, but it lacks the hard-won refinements and lessons that come from years of trial and error. It's like comparing a prototype to a product that's been through several generations of improvement. The difference is like a first-generation product versus a third-generation one. One is still learning to walk, while the other is already running marathons. SpaceX pushes Raptor to extreme pressures and temperatures, demanding the most advanced materials and manufacturing techniques. This relentless pursuit of performance means every component is pushed to its limits. China is still developing the technology and expertise to match those extreme conditions. It's a steep learning curve, and catching up takes time, resources, and a lot of trial and error. So, while Mammoth 1 copies the cycle, it likely runs at lower pressures for now, which limits its performance and efficiency compared to Raptor 3. The result? Raptor 3 isn't just ahead, it's in a different league, setting new standards for what rocket engines can achieve. The devil is in the details, and that's where SpaceX pulls away from the competition. Every bolt, every weld, every line of code is optimized for peak performance. In rocketry, the smallest differences, sometimes invisible to the naked eye, can make all the difference between success and failure, between reaching orbit or falling short. That's what truly sets these engines apart. China's rapid progress often comes from studying and imitating others, a common strategy for catching up. In spaceflight, this means borrowing proven designs, from Soviet engines to SpaceX's innovations. The Mammoth one is the latest example, echoing Raptor's architecture. But copying skips the trial and error that forges true expertise. SpaceX's Raptor was born from countless failures and breakthroughs, experience you can't download from a blueprint. While China builds what works, SpaceX is already building what's next. By the time a copy is ready, the original has evolved. In this race, the finish line keeps moving. SpaceX's real edge isn't just technology, it's speed. While others plan, SpaceX builds, tests, and flies, learning from every failure. At Starbase, prototypes are built and scrapped in weeks, not years. This rapid iteration is their secret weapon. Raptor 1 was complex. Raptor 2 got simpler and stronger. Raptor 3 is even better and cheaper. Each version leapfrogs the last, leaving imitators chasing a moving target. SpaceX's culture empowers risk-taking and fast learning, unlike the slow, cautious pace of traditional programs. In the new space race, the fastest learner wins. Their lead isn't just in hardware, it's in how quickly they can reinvent it. Innovation at rocket speed is hard to catch. That's why SpaceX keeps pulling ahead. Every SpaceX launch is more than a mission, it's a lesson. Each liftoff, each landing, and every anomaly is a chance to learn, adapt, and improve. The company's relentless pace isn't just about breaking records, it's about building a foundation of knowledge that no textbook or simulation can match. With rockets flying almost weekly, SpaceX has built a vast library of real-world data. Every launch adds to a growing archive of telemetry, video, and engineering insights, giving their teams a unique edge in understanding what works and what doesn't, under the harshest conditions imaginable. They know exactly how engines perform under stress, and how to make them last. Decades of trial and error have taught them how to spot tiny issues before they become big problems, and how to push hardware to its limits without crossing the line into failure. Reusability is now routine, with boosters flying over 20 times. What once seemed impossible, catching and reusing rockets, has become almost mundane, thanks to the sheer volume of practice and refinement. Each flight teaches them how to extend rocket life and cut costs. Engineers pore over every returned booster, learning how materials age, how components wear, and how to make the next flight even smoother and more efficient. This cycle, more flights, more data, better rockets, drives prices down and reliability up. It's a feedback loop that rewards experience, making each new launch safer and more affordable than the last. Newcomers like Landspace are just starting this journey, facing steep learning curves and high risks. Their teams are talented and ambitious, but they're still gathering the hard-won lessons that only repeated flights can provide. While they work through first flights, SpaceX is already refining the next generation. Starship, new engines, and advanced manufacturing techniques are all being shaped by the lessons learned from thousands of Falcon 9 launches. The experience gap widens with every launch. Each successful mission puts more distance between the veterans and the rookies, making it harder for newcomers to catch up. In space, reliability and low cost are king, and only years of flight can deliver that. The scars and soot on a Falcon 9 booster aren't just marks of survival, they're proof of lessons learned and value delivered. Mammoth 1's real test is not just working once, but working over and over, cheaply. In the end, it's not the first launch that matters most, it's the 100th. Raptor and Mammoth 1 represent two philosophies. SpaceX embraces risk, learning fast from failure and pushing boundaries. Explosions aren't disasters, they're data. China's approach is cautious, building on proven tech and avoiding public failure. This ensures steady progress but rarely game-changing leaps. SpaceX's boldness lets them solve hard problems quickly, while others inch forward. Landspace's Mammoth 1 is a careful step into territory SpaceX already mapped. In the race to the stars, bold risks create leaders, caution creates followers. Following has its perks. You avoid mistakes and leapfrog some hurdles. Mammoth 1 is a smart move for China, but copying only gets you so far. You'll always be a step behind, building what the leader finished last year. The real race is about innovation speed, not just power or payload. SpaceX's goal is to out-invent and outbuild everyone, faster and cheaper. By the time a copy is ready, SpaceX is already on the next version. True leadership in space comes from imagination and courage, not imitation. Copying gets you in the game, but it won't win it. In the cosmos, you can follow the map, or draw it yourself. SpaceX has chosen to be the cartographer.